Okay, in this section we're going to do 3.3. So this would be identity having to do with cosine. So cosine identity. Cosine, let me call it like this, sum identity. Okay, so we're going to have a new identity having to do with adding quantities before you put it into the cosine. So the first thing I want to emphasize is if we have cosine of something plus something else, alpha plus beta, so those are going to be the quantities we're going to be working with today. The first fact that I've tried to emphasize quite a bit in the past is that this is not equal to cosine alpha plus cosine beta. All right, and again, I've tried to emphasize this quite a bit. In general, you're not allowed to do something like this. For example, square root of alpha plus beta is not equal to square root alpha plus square root beta, right? For example, alpha plus beta, whole thing squared, is not equal to alpha squared plus beta squared, right? And so on. Maybe 1 over alpha plus beta is not equal to 1 over alpha plus 1 over beta, right? So in general, these things are not true. And again, this is all of these here, all of these false statements, in general, is the false statement f of a plus b. It's generally not f of a plus f of b. Okay, so this up here, this cosine statement up here is absolutely false. And so the question you might ask is, well, if this is false here, is there a way we can simplify cosine alpha plus beta so that, if you, into easier pieces, right? And the answer is actually yes. So the actual identity, I'm just going to write it down, is cosine of alpha plus beta is equal to cosine of alpha times cosine of beta minus sine of alpha times sine of beta. All right. So that's the identity that we're going to work on in this section. And we're just going to work on it, assuming it's true. I'm not going to give an explanation for this until later on in the class, because later on in the class we'll have more technology in terms of working with sines and cosines. And so we will be able to verify this identity a lot easier than we can now. All right. If you do look in the book, I believe he does give an explanation for why this is true. But again, at this moment in the class, that explanation is a little messier than what it could be if we just waited a few weeks. All right. So unfortunately, you're just going to have to memorize this statement for now with no justification. But again, we will be justifying it in the near future. Okay, so what that means is this section is focused on essentially how to use this identity, where we can use it, how it can be applied. So let's just start right out. We can use this guy. One way we can use this guy is in actual calculations. So at this moment in our class, what do we know how to calculate? We can calculate cosine of, well, we've supposedly, hopefully, memorized this guy, right? This is cosine of 30 degrees if you want to work in degrees, and that's root 3 over 2, right? What else did we memorize? Cosine of pi over 4, which is cosine of 40 degrees, 45 degrees. That's equal to root 2 over 2. We also know cosine of pi over 3 is cosine of 60 degrees, which is 1/2. All right, so those are 3 that we memorized. We also know a few more, right? We know cosine of 0 is equal to 1. We know cosine of pi over 2 is equal to 0. We know cosine of pi is equal to -1. We know cosine of 2 pi is equal to 1 again. And these guys, the way I think is best to remember them is always to refer to the graph, right? That's the basic graph of cosine. Here is x equals 0, output is 1. This one is pi over 2. This one is pi. This one here is pi over 3 pi over 2. And here we're back to where we started at 2 pi. All right. Okay, or alternatively, you can remember our definition of cosine from our class as the x-coordinate, right, of a point on a unit circle, and all of these guys pop out immediately. Okay, so one thing you'll notice is this is actually a very small list, right? So the question is, how can we use this identity, this new identity that we have, in order to calculate perhaps more values of cosine? So let me start with degrees, because it's probably easier to see with degrees. And then we'll work in radians next. So one example that we can now do that we couldn't do previously was cosine of 75 degrees, right? So what's cosine of 75 degrees? Well, if we can break down this 75 degrees into two smaller pieces, each of which we know the cosines and sines of, then we know we're all set, right? And here's the deal. 75 degrees is 30 degrees plus 45 degrees, right? So this is equal to cosine of 30 degrees plus 45 degrees, right? Because 75 is 30 plus 45. And so now we can use our identity, because our identity literally tells us, right, how to do cosine of one thing plus another thing. Okay, so we just directly just quote the identity. Our identity says this should be cosine of the first guy times cosine of the second guy minus sine of the first guy times sine of the second guy. This is a little small here. 45 degrees. Okay. All right, and the important point here is I know this is one of the ones I've memorized. I know that it's one of the ones I've memorized. I know this, one of the ones I've memorized, and that one as well. Okay, so that means I know everything, all four terms here. So I just write them out. Cosine 30 degrees, root 3 over 2. 45 degrees, root 2 over 2. 30 degrees here, sine of 30 degrees, 1/2. Sine of 45 degrees, root 2 over 2. So now I just put them together. Let's see. Let's write this as root 6 minus root 2 all over 4. And we have cosine of 75 degrees now as an actual concrete number. All right. So this new identity, at the very least, allows us to calculate a bunch of new values of cosine that perhaps before we didn't know how to do. Right. So another example would be cosine of, let's say, 105 degrees. Right? So you just have to think, is there any way I can break up 105 into pieces, right? Into two pieces, each of which I know the sines and cosines of, right? So let's see, 105, we know cosine of 60 degrees, we know cosine of 45 degrees, and sines, right? So that looks okay, right? So 60 degrees plus 45 degrees. Right? We know cosine of 60, we know cosine of 45, we know sine of 60 and sine of 45, so we know we're all set. So this is equal to cos 60 degrees, cos 45 degrees, minus sine 60 degrees, sine 45 degrees. Okay, and always remember, this is a minus sign right there. And again, unfortunately for now, you just have to memorize it. We will explain it in the future. Okay, in any case, I know cos 60 degrees, 1/2, 45 degrees, root 2 over 2. Sine 60, root 3 over 2. Sine of 45, root 2 over 2. And altogether, I get root 2 minus root 6 all over 4. Okay, let me do one more. Cosine of 90 degrees. So this one's a little silly, but I just want to emphasize that obviously, if we break it down into cosine of 60 degrees plus 30 degrees, right, and we use our identity, 60 degrees cos 30 degrees minus sine 60 degrees sine 30 degrees, we should get, on the right-hand side, the actual value of cosine of 90 degrees, right? So we anticipate that our answer should be 0. So let's just check whether it is. If it's not, obviously we've discovered something terrible. But let's see if it works out. So cosine 60 degrees is 1/2, 30 degrees, root 3 over 2, minus sine of 60 degrees is 1/2, sine of 30, root 3 over 2. So that's root 3 minus root 3 over 4, which is indeed 0, right? So this wasn't anything new, but of course, when you do have identities and stuff, you want to actually make sure they kind of fit well with the other facts that you know. All right. Okay, so this was relatively straightforward once you kind of realize how to break down your value into like your 90 degrees into 60 plus 30, or your 75 degrees into 30 plus 45. But it's not necessarily always so obvious how to break it down. And that's certainly the case where you're working in radians. So what about cosine of 7 pi over 12, right? So here's where you really want to be comfortable working with fractions. You want to recognize, well, 7 pi over 12 is cosine of, and you want to break this down again, as usual, into two pieces, where each of the pieces you know the cosines and sines of, right? Well, after working these for a bit, you kind of get a feel for it. And here I know that 7 is 4 plus 3, right? So this is actually 4 pi over 12 plus 3 pi over 12. And the reason I did that is because I know 4 pi over 12 simplifies to 1/3, right? So pi over 3. And then 3 pi over 12, or 3 over 12 simplifies to 1/4, so this is pi over 4. Okay. And, well, here I should recognize I know cosine of pi over 3, I know cosine of pi over 4, I know sine of pi over 3, I know sine of pi over 4, so therefore I know this one is no problem, right? So this is going to be cos pi over 3, cos pi over 4 minus sine pi over 3 sine pi over 4. And so this is going to be, well, cosine pi over 3, again, is 1/2. Pi over 4 is root 2 over 2. Sine pi over 3 is root 3 over 2. Sine of pi over 4 is root 2 over 2. So again, we get root 2 minus root 6 over 4. And of course, that makes sense because this was actually the same example as our 75 degree example. But this one, we're working natively in radians, which of course is always preferred because sines and cosines are naturally defined in radians and not degrees, right? So the only reason I did the degree example was because it's easier to see what's going on, but you really, really, really should get comfortable working with radians. So in the same way, I can break down, for example, cosine 5 pi over 12, right? Well, I know 5 can be broken down as 2 plus 3, right? And I know both of them will cancel with the 12, right? So 2 over 12 is going to be 1/6, right? 3 over 12 is going to be 1/4. And I know pi over 6, I know cosines and sines of pi over 6, I know cosines and sines of pi over 4. So I know that that's probably what I want to do here. So 2 pi over 12 plus 3 pi over 12. That's certainly 5 pi over 12. And then I know, again, I've anticipated that this simplifies to this, which I know that is easy to compute because I've memorized the relevant quantities. Oops. All right, so this is going to be cosine pi over 6, root 3 over 2, root 2 over 2 minus. So you'll see that we've done very similar examples one after the other, but that's because at this moment, we're still somewhat limited in the things that we can calculate, right? But at least it's better than kind of the amount of calculations we could do before. So let's do one more of these. Cosine of 3 pi over 4, right? I know 3 pi over 4 is, well, 3 can be written as 2 plus 1, and I know the 2 can cancel with the 4, so this is 2 pi over 4, plus, pi over 4. And I know that I feel like this is a good step to make because I know cosine and sines of pi over 4. I know 2 pi over 4 is pi over 2, and I know cosines and sines of that. And so this is cosine of pi over 2 plus pi over 4. And again, I just quote the identity and I'm all set. Okay, while I write this, I want to note that This is not necessarily the easiest way to calculate cosine of 3 pi over 4, but it is one way and it certainly works. All right. You can actually reason out cosine of pi over 4 a little easier. But again, this way will always work. 0 times root 2 over 2. I don't really actually care because that's going to be 0 anyway. Minus 1 times root 2 over 2. And so this is minus root 2 over 2. All right. By the way, I knew that this was going to be the case because of the symmetries of cosine. So pi over 2 is right here. Pi over 4 is right here. 3 pi over 4 is right there. Pi is right there. Right? So this one is the one that we're actually figuring out. Or let me do it in a different color here. So this one is the one that we actually want. But it's symmetric to that one right there, except with a negative sign. That one right there is pi over 2, right? Again, this point right there is is a pi over 4. This one right here is pi over 2, right? And then the one right next to it is the one that we're actually looking for, 3 pi over 4. Okay, so I can reason this one out without having to use my identity. And we'll do more of this reasoning in the future. Okay, another type of problem we can do from our new identity. Identity is one that you'll see in the homework. Let's say I want cosine of alpha plus beta. And I know a few things. I know that, so let me write this. What is cosine of alpha plus beta, knowing that alpha is in the first quadrant, comma, sine of alpha is equal to 1/3, comma, beta is in second quadrant, and also that cosine of beta is equal to 1/10. All right. So this is very similar in style to some of the problems we've seen in the past, except more complex because now we have cosine of alpha plus beta. But basically the idea is cosine of alpha plus beta, you just write down the identity, cosine of alpha, cosine of beta, minus sine of alpha, sine of beta, and you look at what you're given, and let's see. We know sine of alpha is 1/3, so that guy here is 1/3. All right. We're literally told cosine beta is 1/10, so that guy right there is 1/10. Okay. So the only question now is what is cosine of alpha and sine of beta, which we're not told explicitly. But each of these guys are literally the kinds of problems that you saw earlier on in the class. Right? Essentially, for the cosine alpha part, you just need to use this fact here, these two facts here. And for the sine beta part, you need to use these facts here, right? For the cosine alpha, we know that alpha is in first quadrant. And sine of alpha is equal to 1/3. So what does that mean? If we think about the original definition of sine and cosine, right? We know that we're in the first quadrant, so we're here. And sine of alpha is 1/3. So let's just draw a random point there, representing alpha here. So this angle represents alpha. We know this height here is 1/3. We know in the definition of sine and cosine, this guy is radius 1, right? And so this length here squared, right? Let me put a question mark. That length squared plus 1/3 squared is equal to 1 squared, right? So this guy squared plus 1/3 squared equals 1 squared. Okay, because we've got a, let me shade it in here. We've got a right triangle right there. Okay, and so question mark, oops. So question mark squared is equal to 1 minus 1/9, which is 8/9. And so question mark is equal to plus or minus square root 8/9, which is plus or minus, simplifying this is going to be square root 8 over square root 9, which is plus or minus 2 root 2 over 3. Okay. Now, should it be plus or minus? Well, I know my guy is in the first quadrant, and so I know it should be plus, right? Because in the first quadrant, the x coordinate always has positive, is positive. Okay. And so that means that cosine of alpha is literally this number right there, except the positive version. So this guy here is 2 root 2 over 3. Okay, and we do the same thing with the sine. Let me do the sine a little differently, just use a different technique. For the sine beta, I know that beta in second quadrant, and I know cos beta is 1/10, right? And in this other technique, I'm just going to draw a triangle with beta here, a right triangle. And if I'm going to create a triangle representing this fact right here. Okay, so if I try to draw a triangle representing this fact, I need opposite over adjacent, adjacent over hypotenuse to be 1/10. So in order to create a triangle that satisfies that, the easiest one is just put 1 here and 10 there, right? Then adjacent over hypotenuse, 1/10, cosine beta, 1/10. So that satisfies this equation. This picture satisfies this equation in a way. And Pythagorean theorem now tells me this guy should be 10 squared minus 1 squared, which is square root of 99, which is 3 root 11. Okay. All right, however, my angle is actually in the second quadrant, and in the second quadrant, I know sine is negative. Right? So this picture here only represents a physical triangle. So of course you're not going to have a negative length right there. Right there. So you always got to be careful to remember that your answer might actually be the negative version of this number right here. Okay? And so, well, beta is in the second quadrant. We're calculating sine of beta, right? We want to know sine of beta is equal to what? And sine of beta, well, sine is negative in the second quadrant. And so it should be the negative version of this. So it should be minus 3 root 11. Okay. Another explanation or another viewpoint is you remember the graph of sine, which you should always remember. Oops, sorry. Let's see. I think I wanted minus 1/10 here. Sorry about that. Minus 1/10. Minus 1/10. And when we drew this, we drew the positive version because we were drawing a physical triangle. Sorry about that. Let's see. This should be positive. I was thinking of cosine, I guess, the whole time. Yeah, this should be positive because in the second quadrant, sine is positive. Okay. And cosine is correctly, it should be negative because cosine looks like that. Second quadrant is this region right there. Okay. All right. So you'll see a couple problems like that. Essentially, it's a problem from the past, except you've now able to deal with situations where you have a sum of two angles. Okay, let's get into a new application. Cosine of, we talked about alpha plus beta. What about this? Right? What if you subtract? That's a natural question to ask, right? We know plus, what about minus? Well, the good news is we actually don't have to memorize this. Sorry about that. We actually don't have to memorize this. Even though after using this quite a bit in the class, you'll probably naturally memorize it, but I would recommend you not actively sit down and try to memorize it, all right? So I would recommend you just remember how to reproduce the identity for this guy. And how do you do that? Well, we're going to rewrite this as cosine of alpha plus negative beta. All right. Now we see a plus sign right there, right? And our identity that we just learned for the plus tells me I need to, this guy here is cosine of the first guy times cosine of the second guy minus sine of the first guy times sine of the second guy. Okay. So we don't need to memorize this identity because it's essentially secretly a version of the first identity that we just learned. And of course, we can simplify this. This is cosine of alpha. Cosine is even, so this is cosine of beta. And then over here, sine is odd, so this should be plus sine of alpha, sine of beta, because that minus sign comes out in front. Okay, so the identity for cosine alpha minus beta is the same, except you've got a plus right there. And again, that comes from the fact that sine is a odd function and cosine is even. All right, now this identity is very useful in exactly the same ways. And let's give an example here. Now we can calculate cosine of pi over 12, right? Because pi over 12 is, actually let me make it slightly more complicated, minus pi over 12, right? Why? Well, cosine minus pi over 12, cosine is even, so you always want to keep these facts in mind, right? Cosine is even, so we can go to here, and then, well, pi over 12 is not the sum of any two things that we can easily deal with, so maybe it's the difference, right? And in fact, if you think about this a little bit, pi over 12 is 4 pi over 12 minus 3 pi over 12, right? 4 minus 3 is 1. And the reason I broke it down in that way is 4 over 12 is cancels nicely, and 3 over 12 cancels nicely. And we end up with two angles that we actually know all the sines and cosines for, right? So this is actually using our new identity. This is cosine of pi over 3, cosine of pi over 4, plus sine of pi over 3, sine of pi over 4. Okay, and so we end up with cosine of pi over 3 is 1/2 root 2 over 2 plus root 3 over 2 root 2 over 2. And so we get root 2 plus root 6 over 4. Okay. So this is an angle that previously we couldn't really calculate as easily. All right. By the way, let me emphasize that we actually don't really need this second identity, because I could have easily just done the problem like this. Minus pi over 12 equals cosine of pi over 12. That step is the same. And then wrote this as cosine of 4 pi over 12 minus 3 pi over 12. This step is the same. And then I do this, cosine of 4 pi over 12 plus negative 3 pi over 12. So I just have to know this trick or this technique, right? And so now I get cosine of, this is cosine of pi over 3 plus negative pi over 4. And so I end up with cosine of pi over 3, cosine of negative pi over 4, minus, using the original identity, because now there's a plus here, right? Minus sine of pi over 3, sine of minus pi over 4. So I don't have to actually, this second identity, I don't have to even memorize it at all, even, right? Because if I'm clever about it, I can always use the plus version of the identity, because when you subtract two things, it's always the same as adding one thing and then plus negative of the other thing, all right? And so if we finish this off, it's of course going to give us the same answer. Cosine pi over 3 is 1/2. Cosine minus pi over 4, cosine is even, so root 2 over 2. And then here, the minus sign is going to pull out because it's a sine. And then we get root 3 over 2, root 2 over 2. Of course, we get the same answer. Okay, one thing to note, the way I did this problem was I broke down, let's make it a little simpler, just pi over 12, into pi over 3 minus pi over 4, but you could do it in another way as well. So we could do this as cosine of pi over 4, pi over 4 minus pi over 6. So this works just as well, because cosine pi over 4 is, if I do common denominators, this guy's going to be 3 pi over 12 minus 2 pi over 12, right? So that I get 1 pi over 12. Okay. And again, I'm all set because I know that and I know that. All right, all the sign. Oh, what I mean is I know all the sines and cosines of pi over 4 and pi over 6. And of course, I'll get the same answer. Okay, so it's not that mysterious because what's happening is I'm essentially calculating cosine of 15 degrees and I'm writing it as 45. Sorry, my first bit of work was writing it as 60 minus 45 degrees. And this second one up here is writing it as 45 degrees minus 30 degrees. So of course both of those are valid. Okay, finally, I think a really, really good exercise is cosine of alpha plus beta plus gamma. So this letter here is gamma. And it kind of looks like a ribbon, something like that. All right. What's the identity for this? What is the formula for this? All right. So what you should be able to do is take the formula that we just learned, cosine of something plus something else, and apply that in order to get the identity for this guy here. All right. The hint is to group the terms, together, and then use the identity twice. All right. And by the way, just to be more precise, my question mark here is I want this to should have cosine alpha, cosine beta, cosine gammas, sine alpha, sine beta, sine gammas, right? So I want this identity in the same spirit as the ones that we've just seen, where you break down the cosine of the sums into individual tiny pieces, right? Of cosines of alpha, beta, gamma, sines of alpha, beta, gamma. So you should try to figure this one out. And another good one to try to figure out, which is much, much more involved, is what's the identity for this? Because obviously the next question is, what is the identity for this? If I know the one for cosine, how do I figure out the one for sine, right? So you can play around with this one. The one above I'll probably likely give as a paper homework, just for you to play around with and try. But the second one we'll talk about next week. All right, and the hint is, again, well, you've probably realized, it's just going to come directly from the cosine identity. All right. Finally, now that we have, again, like I said, every time we have a new identity, we automatically can have new verify problems, right? So what about this? Verify cosine of 2x is equal to cosine squared x minus sine squared x, right? So now we have in our toolbox another identity. So let's try to do it. So answer. Let's do it the way we did in the last section. We'll put a question mark here. We're not sure whether it's true or not. We're trying to confirm it. And on this left-hand side, what we're going to do is we're going to realize cosine 2x is x plus x, right? 2x is x plus x. So this is that. And my motivation for doing this is because I know cosine of the sum of two things can be broken up into easier pieces, right? And those easier pieces are going to involve cosine of x and sine of x, which is what I see on the right-hand side. So essentially what I'm hoping is that it'll clean up very nicely right now when I use the identity. So this is using the identity, cosine of the first guy, x, times cosine of the second guy, minus cosine of the sine of the first guy, times sine of the second guy. Is this equal to cos squared x minus sine squared x? Right, so that problem is the same as this, using our new identity. But we can see that the left-hand side is cos squared x minus sine squared x, just simplifying. Is that equal to cos squared x minus sine squared x? Well, now, this one is obviously true. This one's obviously true, so that one's true, so that one's true, so that one's true. And so we have verified that guy right there. Okay. All right, and we're all set in terms of how to use all the ways that we want to use our identity, at least at the moment. By the way, this identity right there is going to be one of the identities we'll talk about officially in a couple weeks. This verification is actually where it comes from. All right, so this verification actually tells us that this identity is actually true. So it's just simply the idea that we can write 2x as x plus x. That's the key.